This is Digital Pathology Today. Now, here's your host, Dr. Joseph Anderson.
We all want to do the right thing, of course, but how do we know what that is? What is ethics, and what's the difference between ethics and the law? Our guest today is Dr. Brian Jackson, Medical Director of IT, Business Development and Support Services at ARUP, as well as Associate Professor of Pathology and Adjunct Associate Professor of Biomedical Informatics at the University of Utah. We're going to be talking about the foundational principles of ethics in science and medicine. What are the limits of informed consent as it applies to developing new products and utilizing patient data? Is technology evolving faster than our ability to regulate it? How do we get comfortable with and regulate algorithms and devices that appear to be opaque or black box? And what will the future hold as we increasingly have the ability and responsibility to develop these great new tools to help patients?
This episode is brought to you by Leica Biosystems. We are a global leader in cancer diagnostics with a comprehensive portfolio from biopsy to diagnosis. Our mission of advancing cancer diagnostics, improving lives, is at the heart of our corporate culture. Leica Biosystems has been leading adoption of digital pathology for over 20 years with thousands of installations worldwide. If you're interested in learning more about the future of digital pathology, register for our live panel discussion on transforming pathology through innovation. Visit the link in the show notes to register.
Dr. Brian Jackson, welcome to the podcast.
Thank you. I'm excited to be on.
Fantastic. We're really excited to have you because this is of personal interest to me, and I think of many of us in the field, particularly as we move into this new era of artificial intelligence and the idea of ethics. And you recently published a paper titled The Ethics of Artificial Intelligence in Pathology and Laboratory Medicine. So what spurred your interest, and tell us a little bit about the work you've done in this area.
It's been a long journey to get to this point. What got me into healthcare initially was medical informatics. So I grew up in Salt Lake City, had connections to some of the pioneers at Intermountain Healthcare, had some good mentorship there. That got me interested in healthcare as an interesting domain to work in, which led me to medical school. Did a clinical pathology residency, but then promptly looked for opportunities to get back into healthcare IT. So my career has really been a mashup of informatics and laboratory medicine. But I ended up landing at ARUP Laboratories, which is a really interesting entity. It's a large national laboratory business that's operated out of the University of Utah and the Department of Pathology here. On one hand, it's entirely a nonprofit that's a completely controlled entity of the university. On the other hand, it's a business like any other laboratory business. So it's really existing in both worlds at the same time. And it's been fascinating to me to just observe the culture of how there's sort of a business culture that emphasizes profits above everything else. And there's an academic medical culture that I'm not going to say people don't care about resources and selfish interests and things, but in academic medical culture, there's a sincere shared belief that the patient should come first. Let me pause. Do you agree with me on that?
I do. Of course, I wholeheartly agree with you. I mean, you said so much there that I'd like to dive in. But yeah, I completely agree with you. And I think that's what's fascinating about the topic of ethics, right? Is because basically, what is ethics? And people would say, well, we just want to do the right thing. Of course, everyone wants to do the right thing. And then people take it a step further. Well, I just want to do what's best for patients. Well, of course, everyone wants to do what's best for patients, right? But then the question is, well, how do you know? How do you know what's best for patients?
Right, exactly. And it's such a fuzzy concept that has so many dimensions to it. It creates opportunities for cheating, that you can tell yourself that you're doing the right thing. So I'll pick a pharmaceutical example without naming names, but you could be a pharmaceutical company that produces insulin and convince yourself that you're being good for society because you're developing a life-saving drug and you're producing it and manufacturing, distributing it. But if you're pricing it in exploitative ways that keep it out of the hands of a lot of people who need that product so that people are dying for lack of insulin, is that ethical? I would say it's not. Insulin has been in the scientific public domain for many decades. The role of a manufacturer is to produce it at a reasonable profit that can make the business sustainable, but not to maximize profit at the expense of patients if it comes to that. And we see a lot of that going on. So that's just an example of where you can convince yourself that your company's behaving in an ethical way when maybe you're actually not, and you're being just the opposite of that.
No one person really understands enough about the system, right? And then we can delude ourselves or have the various types of biases that we think we're doing the right thing when maybe in fact we're not. And then, like you said, there's all these different silos. Freud kind of called it, I think, the narcissism of minor differences, where you have academicians, you have people in industry, you have private labs, you have all these various different entities. And I think there's kind of the temptation to want to silo and say, well, we're different than you, we're better than you, we work with these interests in mind, you work with those interests. Well, last I checked, we all make our living, very broadly in this thing called medicine or laboratory medicine. So I think it's very fascinating.
Well, you make a really good point. Let me just pause you for a minute. You're sort of implicitly pointing out a bias that's out there that says that if you're in academics, you're a good guy, and if you're in industry, you're suspect. It's a real perception that's out there, and it's a problematic one. It's really problematic. The world that we want to live in is one where we're all good guys and we're all doing the right thing for the patient. There's some reasons why these perceptions have arisen over the years, and they need to be dealt with, but it's not the ideal state.
I became very dubious kind of the field of ethics back when I was a medical student. I was very excited, especially for someone who has not yet gotten into medicine. The idea of ethics coming out of college, undergraduate, it's very appealing. It's very alluring. You want to do the right thing, and you're thinking, well, and the issues are something along the lines of, when do we pull the plug on the respirator of this person who's signed a do not resuscitate order, something like that. That's kind of what you picture as ethics. I remember in my medical school, there was even a course on ethics, or maybe like a 6-week segment of a course. And that's kind of where I became disillusioned, because the instructor would present a case, and then there was some discussion, and then she would always wrap up with, and then here's what the law says. The law says that this is what we have to do in this case closed. And I'm thinking, well, okay, that's the law, but what about ethics? Isn't ethics something else? So thank you very much for writing this paper, because I think ethics kind of has to revolve around principles. So what are these principles, and how do we arrive at these principles loosely? And then how does that relate, and what's the difference between ethics and the law?
Yeah, absolutely. No, I'm really glad you bring up that point, because in a lot of people's minds, even when, I'm not going to name names, but even when we were putting this paper together on ethics in pathology AI, some of the co-authors kept coming back to that, wanting to talk more about law and regulation and compliance. And I kept saying, no, wait a minute, those are related to ethics, but it's not the same thing. And we need to keep our focus clear.
The law is the law, which is great. And you would say roughly the law has in mind ethical principles or but ultimately it's what can get passed in a legislative body. And presumably it reflects at some level the beliefs of the constituents or their elected representatives. But ethics, you kind of need to boil it down to principles. And I think you laid out some principles, and I'll go through them. So it's patient autonomy, beneficence, and non-malfeasance. So first, do no harm, right? Before you can even think about doing good, just don't do harm. Justice, is it fair, equitable to everybody? Scientific inquiry, do we believe in the scientific method? Interestingly, validation. So we'll talk about that. Is that unique to science and lab medicine, or is that an ethical principle in general? And then scientific integrity, right? Is what you're doing stand up? Is it based on sound methods and so forth? It comes down to principles. How did you arrive at those principles, or are those well known?
Well, we started with the principles laid out in the Belmont Report. Most of us in biomedicine are familiar with that, but it was back in the 1970s, there was a U.S. government commission that was brought together because a number of medical research abuses had come to light over the years. A lot of people have heard the Tuskegee study, for example, of syphilis. And it got to the point that really need to be dealt with at a larger level. So let me pause for a minute. Up to that, post-World War II, I think there was a lot of self-satisfaction in the United States in the medical community, because they could point to the Nazis and all the atrocities that happened, with medical experimentation on prisoners and so forth. And the Americans could say, hey, we're obviously not them. They're the bad guys, so we're the good guys. We're pursuing good science for the benefit of mankind. But because ethical principles were not clearly laid out, it allowed a lot of what I'm going to assume were well-meaning researchers to conduct horribly unethical experiments, because they deluded themselves into believing they were doing the right thing. So the Belmont Report came together in the 70s, and they laid out basically the principles of autonomy, beneficence, and justice. And it laid out a fair amount of detail that then got written into federal law and became the basis of of basically medical research oversight over the years. So that was the foundation of writing this paper on AI ethics. Now, I took the liberty of adding some scientific ethics principles into that because I thought they were important to acknowledge as well. They're just as real. They just don't always get talked about in the same frame as quote unquote pure medical ethics.
The principles are kind of the foundation or the bedrock, which we can point to. And the accountability or the enforcement is a different matter. So I have a few questions about the principle. So autonomy. There used to be a principle in medicine called paternalism. We know what's best for you because we're the doctors and you're the patients. Was there a shift in that principle at some point?
I see a long-term shift that's been occurring over many decades on that. Paternalism is just an expression of beneficence. This idea that if you've got the education in the background, that you can make better decisions than people can make for themselves. And so that ultimately, is in competition, if you will, with patient autonomy. My observation is that balance occurs at a cultural level. And what I see in at least American culture, it definitely varies by country, but in American culture, I've definitely seen a long-term shift over the decades to the sort of shared belief autonomy is important and needs to grow in the extent to which we respect it in the medical system.
Paternalism is perhaps a component of beneficence, kind of a generous or positive association with that term. We want to do what's best for you, which is fantastic. And then you said it potentially is in conflict with autonomy, right, where the patient can make their own decisions. Would you think that autonomy is kind of accelerating as we move into the digital age and the internet, and patients could pretty much Google everything or anything and come up to speed and know almost as much as their doctor in some sense very quickly?
Oh, I very much believe that. I think the internet has played a huge role in growing the role of autonomy. Let me just say that the positive side of paternalism is beneficence. The negative side of paternalism is sort of self-protection. That doctors, we're both doctors. People in our field have a natural inclination to sort of protect our role, and so I think that's an unconscious bias. But I think that's a factor that leads us to sometimes ignore autonomy or underappreciate the importance of autonomy in our sort of our self-importance.
Other principles, justice, I think, is self-evident. I think that's probably a topic for a whole different podcast.
I just think of justice as applying these same principles at a population level rather than an individual level.
Scientific inquiry. So I think most people would agree that we accept the scientific method as a way of doing things.
Right. Not just the scientific method, but the scientific goals of creating and disseminating as much knowledge as we can.
You outlined various levels of accountability. So at the individual level, right, that's, as presumably as an individual scientist or clinician, when you're alone with your thoughts in a room, the lowest or highest level, depending on how you want to look at it, then organizational accountability, and then regulatory accountability. So how do these levels play into ethics, and is accountability the right word we're looking for?
Yeah, let me maybe take this one by one. So individual accountability. So the whole Hippocratic Oath tradition, and acknowledging that the exact wording of the Hippocratic Oath is 2,500 years old and obsolete, but at a cultural level, the sort of Hippocratic medical ethics tradition holds that if you are in the role of a clinician, that you need to put the patient first and follow all of these principles. That tradition is applying accountability at the individual professional level. And we have a long tradition of doing that, and it's appropriate, but it's not sufficient. If you think of medical practice 100 years ago or 150 years ago, back in the era when doctors couldn't actually do a whole lot because the technology wasn't there yet, most doctors were functioning as individuals, in their own little local realm. And so what happened to the patient was largely determined by that single doctor-patient interaction. That's not the case today. Today, technology's advanced, but so has the organizational apparatus in which we do healthcare. So what happens to a patient on a day-to-day basis is decreasingly controlled by individual physician decisions and increasingly controlled by the way the systems are designed. And by systems, we're talking organizations, companies, whether they're hospital organizations, pharmaceutical companies, device companies. It's these large organizations who historically have not thought of themselves. If you're the CEO of a hospital and you don't have a medical degree, do you think of the Hippocratic Oath as applying to all of your decision making? I'm not sure you do. If you're the CEO of a drug company, do you see the Hippocratic Oath as applying? No. No, you see the Friedman principle. Going back to Milton Friedman, the famous economist who around 1970 wrote a New York Times editorial saying that the moral responsibility of business is to make profits for its shareholders as long as it doesn't break the law. A horribly misguided, naive statement, lots of negative consequences in our country and in business culture over the past few decades. For accountability to work, you can't just dump it on the doctors because the doctors are not in control of a lot of the factors and decisions that affect patients. You have to extend that accountability upwards, and we have to find better ways to apply it to organizations.
And then so kind of the highest level, depending on how you look at it, is regulatory accountability. So what exactly does that mean? How well do regulatory bodies fill that role? So in laboratory medicine, of course, we have CLIA, which roughly regulates what goes on in your individual laboratory and the validation of your tests and the results you generate for patients in your institution. And then something that's often misunderstood, FDA, which is something different, which in lab medicine roughly relegates reagents or maybe tests that are sold as kits or possibly performed in a single lab for use all over the country or in multiple institutions and so forth. How does CLIA and FDA fill the role of regulatory accountability?
So those are two of the important ones, but there's a broader network of regulatory and legal accountability. I mean, there's still malpractice law, there's antitrust, there's a number of others that you could add to that mix. But I agree, CLIA and FDA are sort of at the top of the list. The way I think about regulatory, it's necessary, but it's not sufficient. And it's in the best interest of society for our regulatory functions to function well, to function efficiently and effectively. But they're never going to be 100% sufficient to meet all of society's needs. The basic reason behind that is the nature of government in lawmaking and regulation making is such that it's a slow process. And I don't see that changing anytime in the near future. We can complain about and try to speed up the FDA, but every time that we try to do that, we run certain risks. Bodies like FDA or any governmental bodies or any regulation is never going to evolve as fast as the technologies themselves. Do you agree with that?
2 points. I think one, people in startups or in health tech, they want to jump in, move fast and break things, as they say, and they find it extremely frustrating. The regulatory process or even, the process of clinically validating something is very slow. So it's frustrating on the one hand, but I also think there is a positive effect of that, right? And that we can be somewhat careful and thoughtful. Maybe it comes back to the principle of, non-malfeasance, right? We do no harm in a sense by being careful, methodical, and somewhat plodding, right? To thoughtfully develop new products, which I think can be a positive. And then second, you said, do I agree that the technology is moving faster than our ability to regulate? And I think absolutely. And so being involved in startup labs and things like that, or new technologies, and inspectors come in, or we're submitting paperwork or applications to CLIA or various bodies. In a sense, we have to guide them. We have to guide the regulators. And in one of our episodes, we talked about regulatory science, how this is kind of a new emerging field where it's going to be, I think in the future, more of a joint effort or a teamwork between physicians and people developing new technologies and regulators to work together really to find what's best and what the best practices are and how to appropriately validate things and regulate things, rather than in this old model where, okay, we've done all the work, we did our experiments, we submitted our paperwork, and then you submit it to these regulatory bodies for the stamp of approval. I think that model's kind of going out the window.
I mean, it'll never totally go out the window, but I do agree with you that your collaboration and communication between industry and regulatory is important. The risk there is regulatory capture. If you're not careful with those relationships, then you do end up with industry accomplishing self-serving ends by steering regulations in ways that are to their benefit, but not necessarily society's. But that's a separate issue. But absolutely, good interaction between industry and regulatory for learning purposes is a good thing. My point was just that the nature of the regulatory process is never going to go as fast as technology development. It's back to the Milton Friedman problem. He basically said, well, if companies obey the law, within the law, they should do as much as they can to maximize profits. But that only works from an ethical standpoint if the law is perfect, if the law covers all of the possible use cases with no loopholes and is completely up to date with the latest technology. And the law is always going to lag technology. So it's an important layer. I believe in regulation. It's never going to be sufficient. There's always going to be a certain inefficiency there that we have to fill with other forms of accountability.
Maybe that's what I was kind of getting at, is that there seems like there's an asymmetry between companies and people who have dedicated years and years of their lives to developing these products, right? And they know best how it works. Then a regulator who just is, maybe even a volunteer from an academic institution, doesn't really know anything about, the work that's been done, who then all of a sudden has to make a decision about it.
Right, absolutely. Yeah, it's always going to be asymmetrical. So some people would get really cynical and say, well, just do away with regulation and let everything be self-regulated, sort of the libertarian approach. And that doesn't work either. We need rule of law in our country for markets to work well, for technology to be safe, and in balancing that is a whole nother topic. The point I was trying to make was just that the regulatory layer is insufficient. We need other forms of accountability. Applying these sort of medical ethics principles at an organizational level and at a product level as organizations work with each other is an area that's been really underexplored.
I definitely agree with you. So let's talk specifically about these principles as it relates to artificial intelligence in digital pathology. AI is such a hot topic, and we're finally going digital in anatomic pathology. The technology's been with us, for 20 plus years, but I think we've had a lot of acceleration in the adoption, particularly over the last year, where we're kind of thrown into the deep end amidst this global pandemic, where we see pathologists now signing out cases remotely a few months or years before they were planning on that being routine practice. So we're all kind of getting excited, getting ready for these new applications of AI that we keep hearing about. And I think there's a few broad categories in which AI will be deployed. One is probably workflow, maybe to triage cases. So get the right cases to the right pathologist in the right, work setting, the right subspecialist and so forth. So maybe not directly affecting patient outcomes, which I think is a reality now. The second one is QC, checking work that has already been done by a human being, which is actually already a reality now in many parts of the world. And then the third, kind of these algorithms that would either assist the human being, probably at first, to make the diagnosis, and then algorithms to come up with predictive and prognostic information. So that's probably a ways off, but we're getting there. This is a very hot topic, or a rife area for ethics inquiries. The first areas, I think where people have questions is with informed consent. Patients go to hospitals all the time, have procedures, and their tissue is removed, right? Say they get a colectomy or they get their gallbladder out. They probably have no idea that at some point in the future, their specimen, which used to be part of their body, is being used to develop a new tool to streamline a workflow in digital pathology, right? Or even to come up with an algorithm to help patients at some point in the future. Let's talk about informed consent. What exactly does that mean? What are the limits? Say you check into the hospital and you sign this yellow sheet of paper that says roughly, I sign over everything to the hospital, and the hospital system can use all my information however they see fit, right? Does that happen? Is that adequate? And what does informed consent truly mean?
I think informed consent, I think you're getting into areas where there are sort of practical limits on how far you can go. You could take informed consent to extremes. Keeping in mind, informed consent arises from the principle of autonomy, that patients should make their own decisions about what happens with their own bodies, and I would argue their own data. But you've got to balance that against actually getting the job done, being able to practically deliver healthcare and so forth. So it's always in tension there. I think the big failure with informed consent is, I think as a medical system, we haven't taken seriously enough the principle that we really need to help patients understand what's going on. Historically, there is a tradition of not wanting patients to know the gory details, the sausage factory part of medicine. We hide stuff. We haven't wanted patients to read their own notes in their medical records, for example. We haven't wanted them to be able to see what happens in the operating room or the surgeon's conversation during the procedure. With modern technology, these things are opening up. Patients can read their own notes. It's even legally mandated. Patients are watching videos of surgery and listening to the surgeon's either appropriate or inappropriate conversations during the procedure because it's part of the video. So there are technologic things that are making it easier for individual patients in individual cases to know what's going on. But what we haven't done as a system to sort of take seriously our educational responsibilities and to pull that curtain down and let patients know this is how healthcare works.
Is there different aspects of informed consent? Because I think, one aspect, or maybe the one that comes to mind, is the patient is informed of the procedure or medicine they're going to take or undergo, right? So it would include saying, well, here's the benefits of doing this surgery. If you do it, this is likely to happen. If you don't do the surgery, this is likely to happen. And you as the patient can weigh the risks and benefits and decide to move ahead. So in some level, that's informed consent. But what about, is my sample going to be used to develop tools in digital pathology or to be involved in some kind of study at some point in the future? Is that part of informed consent, or is that something different?
Well, I think you're raising a really important question. It's the Henrietta Lacks problem, that patients don't really know how their data, let alone their biological samples, are going to be used. So there's really no informing that's going on, and there's not any consenting either, because you can't consent if you don't know what's going on. I'm not saying it's wrong to use patient data for development of technology, or it's wrong to use biological specimens for technology. That gets into the beneficence and the scientific advancement side of ethics. So those are good things to do. I just think we should do a much better job of letting the community broadly know what's going on. To your specific question, when you go in the hospital and they give you the quote unquote consent form, the global broad forms that they shove in front of your face and ask you to sign in order to get admitted, you've probably been to a doctor's office before, right? And you've probably had those forms put in front of your face and asked to sign them, right? And did you read them?
In many cases, it's under duress. You're having wired upper quadrant pain and you need to get into that ER right now.
It's absolutely under duress. And you and I mean, we're about as, we're sophisticated medical consumers. We're insiders. So we would know what to look for. But the vast majority of people wouldn't be able to read those documents and understand them, let alone understand the implications of them. So no, those forms that hospitals give you that say that they can use your data in whatever ways, I do not consider those to be informed consent.
So then this is just in developing these new tools. So we're using patient data, patient tissue samples, and so forth to develop these new tools that we're going to be utilizing in digital pathology. Once we develop the tools, how do we ensure they perform as we think they do? We can certainly point to the principles we discussed earlier, but I think one thing that's emerging is, of course, we want to develop them appropriately. We want to make sure they work, but they're very non-transparent, I think, is the concern. It's a computer algorithm and it's somehow functioning in the background and it's none of your business, or it's way too complicated for you to understand. So don't worry about it, right? Just go with it. How big of a concern is this kind of which may be part of modern life, right? With the black box.
Yeah, it's a huge concern. I would say that the computer science community has done a much better job studying these issues than the medical informatics community. I think we're lagging in medicine, and I think there's some naivete about really understanding where the risks are. But the good news is that our computer science professor colleagues are doing a tremendous amount of research on model opacity and invalidation and different forms of bias and how to study these things. So it's a moving target. One thing I would emphasize, though, and you sort of alluded to this in your question, opacity, it's not an all or nothing kind of a thing. We describe AI as producing opaque models, but they're not all equally opaque. And the more you study them and the more you study their behavior, the more light that gets shed on where the biases might be or the inaccuracies or whatever. And so it reduces the opacity. So I think the principle here is to set up our processes in ways that models that are going to be used in clinical care are studied, and they're studied as much as it seems necessary, which is going to be a lot.
It's not even so much that it is opaque, but there's enormous amounts of data that are generated, right? That it might not be practical to present this data in a journal article or to an inspector, right? It's just so much data, which is one thing.
But this is where it is hard, but this is where we've got a great scientific academic medical community out there with a lot of interest and ability to help with this. And so companies that want to produce AI-driven software for different medical applications have tons of opportunity to partner with research groups who can do independent evaluations and publish them in journals and advance the science. So there's really no excuse for not making a reasonable amount of effort to study the things that are being built.
I tend to agree. We're talking about large amounts of data, which is very intimidating, number one. Number two, we're dealing with complex computer programs, right, which can be very arcane and intimidating, not readily accessible to the average person or even the average physician. So putting, all of that together creates what many people see as opaque, but I think you're right. Ultimately, it's not. But even in the early 2000s, when we first developed multi-analyte classifiers where you're looking at 10 to 20 genes to generate a score. I think even when we started doing that, risk score for prostate cancer, breast cancer, colon cancer, even when we started doing that, I think there were concerns about opacity of what's going on. And I would always say, well, it's really not. It's published, in the various journals. Here's the genes we use to come up with this score. Here's the algorithm. Here's the calculation. It's all right in front of you. And so I think it might have been just a laziness or an intimidation or just, people being uncomfortable with this new era. But I think that was small potatoes compared to where we're headed now. On the one hand, it may not be opaque in literally, but practically for the vast amount of people or even the vast amount of physicians, it is opaque. So, how do we get around that?
I like your mentioning of simpler algorithms as a lead into this. I agree, these things are on a continuum. I would argue that as a laboratory community, we never completely got our arms around the problem of multi-analyte algorithms. You're saying that when people have developed these, they've been studied and published in journals, and I would say that's true for risk scores and things that were developed in academic settings. But there are a lot of risk scores out there that were developed in commercial settings where inner details and the validations have not been published in adequate detail because the goal was not advancing the science. The goal was just coming up with something that they could slap a proprietary branding around and sell. So a lot of the activity in the commercial sector has not been at the level that you're describing, unfortunately. And because we didn't get a handle around that, we're not as well prepared to deal with these much more complex AI models. But we can catch up. I'm an optimist.
Yeah, I hope so. Yeah. So as these things get more and more complex, so then I alluded to the AI systems are going to be perhaps making the diagnosis or doing things that a human being used to do, or developing tools to add predictive and prognostic components on top of what the human being is already doing. So my question is, let me pose this to you. One concern or question I've heard is, well, what obligation do I as the pathologist or the practitioner have? Is it ethical to disagree with an AI system? Because medicine is an art as well as a science. In the old days, where it was a human being looking through the microscope, you say that's your opinion. You're looking at that, and you've had 10 years of experience, and that's your best judgment. And your colleague down the hall came up with a slightly different conclusion. He's got 12 years of experience, but maybe that's not his area. It's okay, yeah, difference of opinion, whatever. But now, when we can train these systems on thousands and thousands and thousands, hundreds of thousands of cases, you can develop an algorithm or a tool based on way more experience than any human being could ever hope to have. Presumably, it takes out the emotional components or the human factor, and it's going to be accurate, precise, reproducible, and based on much more experience. How do we ensure that was developed appropriately? And then what's our obligation? How do we work with a tool like that? Is it ethical to disagree with the conclusions?
You raised so many questions in that question. Which one should I start with? Let me start with this one. You're making a really strong case that there are areas where AI can perform better than human pathologists. And I agree with you. Human pathologists are not all that perfect. There are concordant studies that show that pathologists don't always agree with each other. They're not always even internally consistent. They can slip up and miss things. There are all kinds of errors that humans can make, and technology can help with those. I am a fan of AI in pathology. On the other hand, there are some types of errors that computers are more prone to than the humans. And I'm not going to use the right language here. There are other people who write in this area that can do this more eloquently than I, but there's some types of areas where the human can be sort of ballpark correct, but may miss a detail. But a computer may be better at hitting those details, but may be more vulnerable to being way outside the ballpark. And there's no self-awareness on the computer's part. So for those reasons, I really suspect that the most productive area of AI research is going to be human assistance rather than human replacement. And I think that's where the money's going to be. I think that's where the opportunity is going to be. I think companies like Google that go for the sexy stuff, or IBM that go for the sexy stuff with IBM Watson to try to replace physician decision-making are really barking up the wrong tree. And they need to look for tools to make the human's decisions more and more reliable and less error-prone. I think that's where the opportunity is. That was one area that you were talking about. But you're also talking about the role of the individual in knowing whether to trust the system. And that's complicated, because you're right. You know, an individual pathologist, do they have to individually spend a year studying a system to decide whether it's trustworthy or not? Do they go with their gut feel, which is going to be wildly inaccurate? I don't think that's a fair thing to dump on the lap of a pathologist. I think we need, systems and processes at the organizational level to make sure that these systems are trustworthy before they're allowed to be used in clinical practice. And then the responsibility of the individual pathologist becomes just to make sure the process got followed, rather than expecting them to dig into the model in great detail when they may not have the expertise to do that.
I think you're right. I think the next big step is going to be physician assistance, rather than physician replacement. I think that's what we're looking for in the short to medium term.
And I'll go a step further, because you asked this question, so I feel obligated to answer it. Once a tool has been shown to improve decision making, I absolutely agree there's an ethical obligation to use that tool. Cardiologists who won't use an echocardiogram because they don't understand the details of it, or they'd rather use their stethoscope over an echocardiogram. I mean, that's just Luddite. I mean, that's unethical. So it's going to be the same thing in pathology, but that happens once the tool has been sufficiently validated that the community agrees that yes, this is a requirement for clinical care.
Dr. Brian Jackson from University of Utah and ARUP Laboratories, thank you so much for being with us. Now, before we wrap up, maybe just tell us what excites you, or what do you see on the horizon? What do we have to look forward to?
Oh, we have so much on the horizon. Okay, I'm going to give you an answer that's not a technology answer, because given the nature of our conversation, you can tell I'm sort of focused on organizational dynamics rather than the technology per se. But in order to get maximum technologic benefit, the organizations that are developing and using technologies need to have relationships that support safety of the technologies. So what I'm really excited about, honestly, is stakeholder capitalism. That corporations who make medical products, I see a slow trend in the for-profit business world toward more transparency and reporting of non-financial metrics so that they can be held accountable for their social impact. A lot of this is happening in the environmental realm, green impact and that kind of thing. But in the medical world, I see a real opportunity here for companies, even for-profit companies that are engaging in things like artificial intelligence, to behave in ethically aligned ways with the medical community. And I think we're going to have a lot more productive interactions and much better and safer products as a result.
Increased opportunities to help benefit patients and ultimately make life better for all of us. Our guest has been Dr. Brian Jackson. We'll see you next time on Digital Pathology Today.
This has been Digital Pathology Today. Please be sure to subscribe. Thanks for listening.